Alright, chemists, so let's talk about a separation technique for separating a heterogeneous mixture. Decantation. We can use it for separating both sedimentations and immiscible liquids. So our goal here is to understand how it works. It's really simple, but also what the physical property is that the separation is based on. If this is your vocabulary, just pause the video, get this written down, and that way you can refer back to it as we continue on through the lesson. So decantation, it's a separation technique based on the density of two components of a homogeneous mixture. Now, homogeneous mixtures means that they've got a different consistency throughout, and we can see two types here. We can see a liquid and a liquid with oil and water, or we can see a precipitate with supernatant, or sand, water, any form of sediment that you would think of. Now, the density means that the more dense one will sink to the bottom, and that's always the case. Even if we just give it enough time, these immiscible solute mixtures will always sediment out. So as we said, those components are separated out based on density. And once we've allowed them to settle, it's actually quite as simple as either pouring the top layer off, or if we're like this separation funnel down here, just turning the tap and letting the bottom layer pour off. So we either pour the top layer off or allow the bottom one to drain out, which is called pouring off still. It's really efficient. It's very low energy, but there's always that limitation on purity. So if we're pouring from, say, this situation here, where we have a solid and a liquid, in the precipitate or the solid, there'll always be a bit of the supernatant or liquid in the solution left over until we sort of evaporate that off. And it's really hard to get a high purity in the liquid solution we're pouring off. When it comes to pouring off with a liquid-liquid mixture, it's really hard to get a high purity when you hit sort of this zone. Like, you'll tend to always get a little bit of overlap one way or the other. No, I mean, not always, but it's just, yeah, there'll always be a small amount. So the purity is compromised a little bit. The better equipment you have, the more pure a sample you can get, but there's still that compromise there for efficiency and energy. All right, I hope that made a lot of sense. If you have any questions, put them in the comments below, and we'll get to them as quick as we can. Hit subscribe so you can keep up with everything we're putting out in the future. And yeah, thanks for watching. Bye now.